if you would have seen, if you would have seen torque in the previous class, this is actually it has similarities to find the way we find out torque. There is a similarity in finding out in angular momentum also. How an angular momentum of a particle is defined is, suppose there is torque, whatever I do, there is a particle here which is going having a momentum p vector in the direction. So if you want to find out the angular momentum of the particle about this point, what you will do is similar to torque. You will draw an arrow from that point to the momentum where the momentum is acting there, and then what you will try to do is this is an r vector, this is a p vector, then torque is equal to, sorry, angular momentum L vector is equal to r cross p vector, that is r cross mv vector. So this is one of the, like how torque will be there, torque will be there, r cross f vector. Similarly,
Yes, sir.
torque will be, did you see that lecture?
Yes, sir.
The exact formula will be like this. Now the other formulas also, like torque is equal to in magnitude for a system of particle, that is I alpha, right? For a body,
Yes, sir.
or
Tau is equal to IR.
equal to magnitude I omega. Got it? Then, like this, from torque also I taught you. How can this be solved?
So the screen is gone, sir.
Now, in torque, what did he tell you?
Yes, sir.
How to find out this one? So
Yes, sir.
try to find out the angle between them, theta. Then we can write this as RF sin theta. Similarly, here also cos L can be written as R, magnitude of R, into magnitude of P, into sine of angle between both of them. Why this is the angle? Because two vectors between angle is actually they either tail and tail should match, or either head and head should match. Then the angle between them is the angle. And either way, this can be R sin theta into P. R sin theta is, if you extend that P like this, R sin theta is actually the perpendicular distance. This is R, this is theta, this will also become theta. This will become R sin theta, got it? R sin theta into
Yes, sir.
P. That is R sin theta is the perpendicular distance of the momentum vector from the point above which you have to find out angular momentum. That you can write it as R perpendicular into P. This is also called as moment arm. Like in force also, torque also, you can see that is the lever arm or moment arm. So this angular momentum, torque can also be called as what? Moment of force, right? Because you will write as R cross F, right?
Yes, sir.
R cross F, when you're writing, we can write torque is also name as, we can name torque also as moment of force. This also called as lever arm, or this length is also called as lever arm. Similarly, we can write it as, another way is, we can try to find out the P vector which is perpendicular to this one and which is parallel to this one. Due to parallel component, there will not be any angular momentum. Only perpendicular component will give you angular momentum. This can also be written as r into p. Now, if this is p cos theta, this will be p sin theta, right?
Yes, sir.
R into p sin theta also we can write for a particle, given particle. That is what? L vector is equal to R into p perpendicular. Anyway, we can try to find out the magnitude. So according to the situation, we'll try to use the formula. System of particles is there. The moment of inertia is known. Omega is known. Then we'll try to use the formula, this one. If a particle is there, moment we need to use. If you know the point above which you have to find out angular momentum, then we will try to use this formula rp sin theta or r sin theta into p, or otherwise r into p sin theta, r into p perpendicular. Got it?
Yes, sir.
Whatever I taught you in torque, similar. So because you told torque as moment of force, we can say angular momentum as moment of, because r cross f, you wrote it as moment of force. Here also r cross p, that is moment of linear momentum. Okay. If in exam instead of angular momentum, if it is given as moment of linear momentum, then also we'll have the same answer. Got it? Go ahead. Directly formula. L vector is equal to I into omega vector if for a given body is rotating like about this axis with omega. So if it has moment of inertia of I about the given axis, so angular momentum can be written as I omega, right?
Yes, sir.
Now I will try to find out dl by dt, rate of angular momentum. Okay? That is nothing but what? Rate of change of linear momentum is force. Rate of change of angular momentum is
Force.
torque. Rate of change of linear momentum is force. Rate of change of angular momentum is torque.
Okay. Oh, yes, sir.
Dl by dt is equal to what? I for a given body will be fixed, and that will be equal to d omega by dt, right? Because L is equal to I omega. This can be written as what? I alpha, right?
Yes, sir.
Torque, another formula is I alpha. We took there. It's I mentioned in talk topic also. Are you getting it?
Yes, sir.
Similar connection. Like force is equal to dp by dt, rate of change of momentum. Torque is equal to dl by dt, rate of change of angular momentum. Okay. So then another way we wrote as dp vector is equal to f dt, right?
Yes, sir.
Integral dp, integral of dt, if we applied, what did we find out? Integral dp is what? Impulse, linear impulse. We can also call as impulse. Remember this?
Yes, sir.
So
So your voice is breaking, sir.
continuously
Yeah.
from when?
Uh, from array, from something like 40 something 340.
Why didn't you tell me? Once you mute yourself and just
Okay.
chat with me. Okay, now can you hear? Chat with me.
Yes, sir.
Now also the voice.
Now I can hear, sir. Maybe my problem.
No, because this is happening. I don't know. With this laptop only, this the problem. There's something because the old laptop I gave it to repair, and this is another
Now I can hear, sir. Now I can hear.
noise.
No, there is no noise now.
If you feeling it is coming noise, just you mute yourself and check it once. Okay. In this laptop,
Okay.
it's working like that.
Okay.
Impulse is equal to p final vector minus p initial vector. So dp is p final minus p initial, that is equal to impulse, that is equal to f dt, integral f average into dt. So similarly, what we can do is here integral dl is equal to tau dt. So this will give you angular impulse. L final minus L initial, or dl or integral tau dt will give you angular impulse. Okay.
Yes, sir.
Angular impulse also will have same units as angular momentum, units and dimensions. Impulse is impulse is actually nothing but the momentum given to change the momentum of a given body. Okay. Impulse is given to a body to change the linear momentum of the body. Similarly, angular impulse is given to a body to change the angular momentum of a body. Okay.
Okay, sir.
Then how to find out, you know, right? Because how torque is found out, R cross F. Similarly, R cross P, you can use the formulas and find out what how angular momentum is also figured out. Okay.
Yes, sir.
There is one of the question is asked of this one. A particle is there which is going parallel to x-axis like this, uh, with constant velocity, given mass is fixed. It is a constant linear momentum. So now, what is the angular momentum of the this particle about the origin? Whether it will be remain constant, variable, increase, decrease with time. Like this, it is going. Okay. One of the year this question is asked. You can try this question out.
It will be variable, sir.
It will be variable. Why did you say?
If it has to be constant, then both should exert same angular momentum, no, sir.
What both should? There's only one particle here. This is the point above which you have to find out angular momentum.
Oh, I saw this like another end. Okay, fine.
This particle angular momentum about this point origin, and this particle is moving parallel to x-axis at a constant velocity.
Once I'll write the question, so dictate the question.
So a particle is moving with a constant velocity parallel to x-axis. What is the angular momentum of the given particle? How will the angular momentum of the given particle vary with respect to origin?
Done, sir.
What is it? Tell me.
I got constant because L is equal to R cross of P. That is R cross of MV, no, sir.
Uh, no, R cross P. So P
Huh.
is MV, but R cross is what? R perpendicular into
R perpendicular into that.
um, R perpendicular is nothing but if you extend the P vector and draw the perpendicular, this is remaining. R perpendicular is constant actually
Constant. Yes, sir.
between the momentum vector line and the point of above which you want to find out. You have to find out angular momentum. So this R perpendicular is constant, moment is also constant because the given it is going in a straight line with constant velocity. So what we can say is here the angular momentum will be constant. This is one of the previous year's question. Okay. Yeah. You can find out the so you can try to find out the direction also. This vector direction will be how much if it is going in the positive y-axis, positive side of the y-axis, and in the positive x direction. It is in the positive y direction, and also it is going in the positive x direction. So r cross p will be in the negative z direction. Take it, isn't it?
1 minute, sir.
You keep your first hand in the r vector direction, and you try to rotate your fingers in the direction of momentum. You will get the finger in the direction of the angular momentum vector. So angular momentum,
Okay.
you want to write out magnitude. If you know this distance has something called some q distance, then the answer will be q into mv will be the magnitude of this angular momentum. The direction will be minus k cap will be the direction. How to find it?
Yes, sir.
Keep your first hand in the r vector direction and you curl your fingers in the momentum vector direction, then you automatically get the final angular momentum vector direction. Otherwise, the formula wise, r vector is equal to how much? R vector is in the direction of positive y-axis.
Yes, sir.
So j cap something, some positive yj cap,
Okay.
yj cap. The p vector is how much? mv x cap, mv I cap. So if j cross I is what? Y mb, if we say to bring out outside mb j cap, j cross how much? Minus k, right?
Yes, sir.
If you want to write this I j k cap, if you are doing clockwise, positive it will be there. I cross.
Minus K cap.
Okay. So j cross I is you're going in the anti-clockwise direction. That will be minus k cap. Got it?
Yes, sir.
Direction basis you can solve the problem, or otherwise you can
Yes.
solve the problem by doing what this vectorial thing. Another way of question. Given a solid cylinder of mass, solid cylinder of mass 10 kg, rotates about its axis with an angular speed of 50 radian per second. Angular speed,
Rotates about.
its axis. That means what? If cylinder is there, about its axis, like this. This is the axis about its 50 radian per second angular speed. The radius of the cylinder is 0.5 meters. What is the magnitude of angular momentum of the cylinder about its axis? Okay. Radius of the cylinder.
Sir, I got 250, sir.
250. Angular momentum, what is the formula you took here? I omega.
Huh.
Magnitude of angular momentum is equal to I omega. Right. I into magnitude of angular speed. Angular velocity is angular speed. So I is what? For a solid cylinder, that will be mr square by solid cylinder,
But
mr square by 2. It's like disk. So mr square by 2 is, m is what, 10 kg, r is 0.5, that is 0.5 whole square is 0.25, right?
yes, sir.
2 5 is a 525 is a 125, that is 1.25 is the moment of inertia. 1.25 kg meter square. Then coming to I omega, that is 1.25 into omega is 50 radian per second, right? What will be the answer? That is into
1 minute, sir.
2 by 2 can do. So that is 125 by 125 by 2. That is
64.5.
60. 2 6 is 12.
So
2 2 is 62.5.
2 6 are 12, 2 4's 0.5, no, sir.
2 2 is of
4 twos.
angular momentum, or otherwise MVR, mass into velocity, kg meter square, kg meter square, uh, MVR per second, kg meter square per second, or otherwise joule second also we can write. Okay.
Yes, sir.
Then a very important topic. Number of times questions are asked on this also. That is EOAM, that is conservation. Conservation of angular momentum. We have seen conservation of linear momentum, right? Similarly, this
Yes, sir.
is also so important. Conservation of angular momentum. How angular momentum will be conserved. In linear momentum, what did we study? You remember? If net external force is zero, that means dp by dt will be zero. That is delta p by delta d is equal to zero. That implies delta p is equal to 0. That implies p final minus p initial is equal to 0. That is p final is equal to p initial. That means momentum, linear momentum of the system remains constant. Do you remember that?
Yes, sir.
But we have solved number of questions on it, and I have sent you a video lecture on H.C. Verma,
Hmm.
and you will find number of questions on this. Linear momentum of the system will be conserved. Net external force zero means bomb exploding question, bullet gun question. Then man walking on the uh, boat question. Projectile breaking down at the given point question. Then suddenly collision happen. Collision. All are based on topic of physics. Momentum of the system will be remain conserved. Will remain conserved. Similarly, same pattern here follows here. If torque net external is equal to 0, dl by dt is equal to 0. That means delta L is equal to 0. Implies L final minus L initial is equal to 0. Similarly, if you think L final net external torque over a period of time in the given direction is then angular momentum in the direction change will not change. So this angular momentum will remain correct. Sometimes
Yes, sir.
formula can also be represented like this. Angular momentum will be written as I1 omega 1 for a given body is equal to I2 omega 2. I2 omega 2 is not exactly I2 omega 2, the final momentum of the system.
Okay.
Omega 1 is like initial momentum of the system. Okay. That is why we can see some examples. Uh, ice dancers will be there, where they will change the position of their hands across the axis. So when they,
Yes, sir.
because the net torque on them is zero, either their angular momentum can be increased or decreased just by themselves. Suppose if they stretch their hands, their moment of inertia is increasing because the mass distribution is,
Hmm.
distance is increasing. Moment of inertia is increasing, then automatically omega should decrease so that their angular momentum is conserved. Omega will be decreased when they're dancing like this. The omega will be decreased when they close their hands very closely to the axis like this or what some axis if they've been close. Suddenly their omega will increase because the uh, moment of inertia has decreased. Got it? To
Yes, sir.
note that angular momentum is conserved. That is some of the examples. Okay, we can solve some very important questions on this. Okay. This is also just I'll try to place those questions. This is one good quality question, which is the question is also given in HC Verma also. It was asked in one of the medical exams in 2003. A thin circular ring of mass is rotating about its axis with constant angular velocity omega. A thin circular ring moving about its axis with angular velocity omega. Four objects, each of mass m, are kept gently. Here, these words are important. Are kept gently to the opposite ends of the two perpendicular diameters of the ring. It means one mass here, one mass here, one mass. All the opposite ends of the perpendicular diameters. Like this. This indicates in all the situations, similar scenarios, gently keeping and all the scenarios. Otherwise, they kept slowly or anyway. All the scenarios, at least if the question is coming from this topic, that is ensuring you that torque net external is equal to how much?
0.
Zero. Okay. Torque net external is zero, then what is happening? Angular momentum should be conserved. L initial is equal to L final. Initial angular momentum is what? I omega. So for what is the I here about its axis? mr square into ring mass m. So ring mass is given as capital M. So I1 omega 1 initial angular momentum is equal to final angular momentum I2 omega 2. So initial I1 is too much only for ring capital M r square into what is the angular speed? That is omega. That should be equal to final angle in moment of inertia. You need to find out. Final moment of inertia is what? One is due to ring mr square plus
4m r square.
four particles which are at a distance of r from the axis, small r, radius r. Okay, whatever the radius is there, that r, that is not small r. I took the radius as capital R. So 4 into small m into r square will be the total moment of inertia, that is due to ring mr square to all the other four particles. This is 4 mr square into omega 2. So then the answer will be omega 2 will be mr square divided by mr square omega divided by mr square plus 4 mr square. So then r square gets cancelled. Then the answer omega 2 will be equal to m omega by m plus
M plus 4m.
4.
Yes, sir.
Similar question we asked for disk also. And that can
Disk moment of inertia we should substitute and
mr
find out.
uh, based on this you can solve number of angular momentum also.
Sir, your voice broke. Okay.
Just try to mute yourself. So here the option will be B option.
Yes, sir.
Uh, There's another question which is asked in 1991.
Which one, sir?
That question number is 87 in the question. This is a question. A particle of mass m is equal to 5 kg is moving with a uniform speed v is equal to 3 root 2
It will be 0 only, no, sir.
xy plane along the line y is equal to x plus 4. Y is equal to x plus 4 in the sense y plus 4 means x 0 equal
Straight line.
straight line, but y is equal to x 0 means it starts from 4, right?
Yes, sir. It cuts like this.
So if you keep x is equal to 0, y is equal to 0, then x is equal to minus 4. It means it will cut at minus 4, comma 0, here 0, comma 4. This is a line. Along this line, the particle is moving with a velocity speed 3 root 2. The magnitude of the angular momentum of the particle about the origin. Why it will be 0? About the origin. Means from here you need to draw perpendicular distance to the momentum vector. Momentum vector will be in this direction along this line. So now perpendicular distance between that line and origin is this one. This is the perpendicular distance. If you see this one, this is a triangle. So this distance is 4. This one magnitude is 4, and this distance will be 4 root 2. So now, what will be the distance between the perpendicular distance between that line and the point?
Formula is there for that.
What is the formula?
Um, ax plus by plus c by under root of a square plus b square.
Is it required? It's a big formula. Is there no other way? Okay. As a mathematics student, you can try it. Suppose consider yourself as preparing for medical exams. You don't use the formula. Is there any other way to it? Easy way?
Okay. Distance you can take, no, sir,
No?
from those points.
What is the distance you can say? It's a triangle, right? Because
Hmm.
0, comma 4, it is minus 4, comma 0. Exactly, it is a perpendicular bisector, right? It will be perpendicular. Exactly point. Okay. Take,
Yes, sir.
this is 4, this is 4. This is 4, this is 4, this is 4 root 2. Then the distance will be, this one will be 2 root 2 and this one will be 2 root 2. Half of distance. Now this is the right angle triangle, right? That is the right
Yes.
angle. So now this is how much? This is the hypotenuse. 2 root 2 is the hypotenuse. That is 4 square. Uh, x is equal to 2 root 2 whole square minus x square is equal to 2 root 2 whole square minus 4 square.
It will be
No, sorry.
minus 8, no, sir.
This is hypotenuse here. This is the hypotenuse. Okay. 4 is the hypotenuse.
4 square minus 2 root 2 square.
4 square minus 16. It is 16 minus 8. Is equal to 2 root 2. The perpendicular distance is 2 root 2. Mass is 5 kg. Velocity is 3 root 2. If you multiply, what will happen? 2 3 is a 6. 6 5 is a 30. 30 into root 2 is 2. Answer will be 60 units. But just units are given. You understand?
Yes, sir.
Hypotenuse will be that 4. 2 root 2 will be one of the side. We need to find the other side. So if we find it, we'll get the other side. X is equal to root 2. Perpendicular distance is 2 root 2. R into M is 5 kg into velocity is 3 root 2. That's speed. We'll get 60 units is the answer. Other way, your formula is what? How to write the perpendicular distance? Tell me the mathematics formula.
Ax plus by plus c by under root a square plus b square.
What is
1.
from the origin to find out the distance, right? This formula.
Yes, sir.
Okay. That is A is here 1.
That also by root 2 it will be
1 into X is how much?
0, no, sir, because origin.
Okay. Ax plus by, that is again
0.
minus 1 into 0. 0 plus C is how much? 4.
4.
Divided by root over a square, that is 1 plus 1
Root 2.
by root 2. That is 2 into 2 by root 2. That is 2.
Root 2.
This is the perpendicular distance. You supply this 2 root 2 in perpendicular distance formula into mass into speed. You will get the angular momentum. This is one of the practical examples. Okay.
Yes, sir.
Similar questions will be there. You can try out in your previous mains also on angular momentum and conservation of angular momentum. Okay. Next topic will be, we'll discuss the remaining part in the next class.